Oh, hello. Today we're going to look at exploring equivalent fractions, which is something we need to do in order to be able to add and subtract fractions later on, because we need to make them into equivalents. But this is a nice way of exploring so that they get the connection between why we end up multiplying a fraction to make an equivalent, or even dividing. So this is a similar method as to what I showed in terms of just showing multiplication using acetates. So on the piece of paper I have printed out a table, and this part is shaded, this part isn't. The fraction we've got is 1/2. So we've had the whole, we've split it into two. I've got one of the two pieces, or the other way of looking at it is 1 divided by 2, and that's one part of it. Now as such, going back to the very basics of times tables, we get one lot, okay, or 1 times rather, not one lot, 1 times a half, and we get a half, okay. Now then, we want to make an equivalent fraction to this, so we now can use our times tables as such and multiply this fraction by 2, okay. Now then, here we have now got, still the half hasn't changed, but we can see it's been divided into more pieces. We've got 1, 2 out of the 1, 2, 3, 4 pieces that have been coloured in. Okay, that's using the 2 slide. Let's move up and use the 3. There we are. We're timesing by 3. And now we have got still exactly the same amount shaded in, so we know it's the same fraction. So we've got 1, 2, 3. Now out of the 1, 2, 3, 4, 5, 6. Okay. Let's move it up and get 4 parts. So now we're timesing by 4, and we overlay it, and we get 1, 2, 3, 4. Out of the 1, 2, 3, 4, 5, 6, 7, 8. Now the nice thing to do with equivalent fractions is pattern based, and it's pattern based on your times tables. The top row here is going up in 1, it's the 1 times tables. 1, 2, 3, 4. And the bottom is going up in 2, 4, 6, 8. Okay? So there's that little relationship which children can explore. Let's just try another one. Okay, oops, hold on a second. I'll do 2 more and then we'll talk about how. So here we've got a third, 1 out of the 3, or a whole that has been divided into 3. Okay, a third. We also know, going back to the basics, that if we have times that by 1, we simply get 1/3. This is the 1. If we have 2, okay, we now get 2 out of the 1, 2, 3, 4, 5, 6. Okay, now we can start to predict, okay, well, what do you think it's going to be? This is now 3, 6, maybe too early to predict, but you can always get prediction in there. So we now try with the 3. So let's bring the part that's been divided by 3 over. And we've got 1, 2, 3, 4, 5, sorry, 3 shaded in out of 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we can start to look at the patterns. The pattern on the top is 1, 2, 3. Ooh, what's going to come next? Possibly a 4. The pattern on the bottom is 3, 6, 9. 3 times tables. 12 is going to come next. And we check this out. Okay, we always check it out. So we take 3 and we replace it 4 and 4. And there we are. We have got 1, 2, 3, 4. Whee, the 4 expected. And 1 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Brilliant. Now we're getting the idea that we look at the top to see the pattern on the top, and we look at the bottom and use the bottom times tables to generate equivalent fractions. Let's try a harder fraction. Let's try something that's coloured in a little bit more. Here we go. Okay, now we have got 2 out of the 3 pieces, or the whole has been split into 3 pieces, and we're looking at 2 of them. Yes? Right, now, again, if you want, go back to the basics. We've got 1 lot, or 1 times rather, 2/3, and we get 2/3. We now divide it, sorry, such times number, and we have got 1, 2, 3, 4 on the top, and we have got 6 on the bottom. Now this is starting to look like the 2 times table on the top. This is the 3 times table on the bottom. Let's take the next one, which is the 3rd. Sorry about my arm. Okay, also the 3s. I do need to think these again possibly. 1, 2, 3, 4, 5, 6 out of the 9. Okay, and that's where you have got your equivalent fractions. But here we've got 2, 4, 6, 3, 6, 9. So, let's predict. Okay, so if that's going up 2, 4, 6, the chances are it's a pattern, and I'm going to be having 8 on the top, and 3, 6, 9, 12 on the bottom. Okay, let's now multiply our fraction by 4 and see what happens. 1, 2, 3, 4. Okay, there we go. There's 1, 2, 3, 4, 5, 6, 7, 8. The 8 expected. Out of the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Whee! Okay, brilliant. It could work the other way around as well. If you have got 8 12s, and the child now has to think, what's the highest common factor which goes into 8 and also goes into 12? Which number fits into 8 that also fits into 12? What do we have to divide this by and this by to get back to that very basic fraction that lies beneath here? Well, the highest common factor for us, as we know, is to divide by 4 and divide by 4. Which is what I actually multiplied by. And if I divide 8 by 4, I get 2. And if I divide 12 by 4, I get 3. I go back to what it was, and I can physically remove that to find the inverse as well. Okay? Likewise, and I hope this is quite clear, if I have got the 6 9s, okay, there we are, 6 9s, what is it, which is the highest number that fits into 6 that also fits into 9? Shady here, isn't it? Divide by 3 and divide by 3. Okay, now pulling it away, I am getting rid of that times by 3. I'm doing the inverse of dividing. 3 fits into 6 twice, 3 fits into 9 3 times. Okay, it's a lovely way of doing it because it will help them eventually find out those equivalent fractions, which of course is what they need for adding and subtracting. I hope that was clear. I know sometimes my wording may not have been correct, so I do apologise, but it is very early in the morning. I hope that's all right for you now.